Assalamu alaikum wa rahmatullahi wa barakatuh. Hi there, it's Kareem al along with Mohamed al-Essaily. Looking forward to what should be a really exciting video.
Hi there, it's Martin Tyler for you, along with Alan Smith. Looking forward to what should be a really exciting match.
I think so too.
In this video, we'll be covering hybridization, which should have been taken the week of recording, the previous week. In terms of explanation of hybridization, it is the mixing of two or more atomic orbitals, which are usually pre-existing s and p orbitals, to form a new set of hybrid orbitals, such as sp, sp2, and sp3. Essentially, what you need to know is that the number of electron domains, including lone pairs, for a certain atom in a Lewis structure determines its hybridization. In most cases, it's possible to determine the number of electron domains indirectly via the angles, which could be given separately, or you could also obtain it from the molecular/electron geometry. The hybridization electron configuration is always one less than the number of electron domains. So for example, if one specific atom were to have two electron domains surrounding it, its hybridization would be sp. If one specific atom were to have three electron domains surrounding it, its hybridization would be sp2. If one specific atom were to have four electron domains surrounding it, its hybridization would be sp3. Question 1. When the reaction above occurs, this reaction up here, does the hybridization of the carbon atoms change? This is the Lewis diagrams of both before and after. First of all, we did it how any other Lewis structure, and we got the electron pool that we'll be using. And so since carbon 2 is in group 14, 4 electrons and 2, so it's 8. 8 and 2, that's 10, because each hydrogen has one valence electron. We have 10 electrons to work with. We distributed the carbon and hydrogen atoms accordingly in terms of electronegativity, where hydrogen is an exception, and so carbon is put in the middle, and with each hydrogen coming out of one carbon, and this is how it looks. Now, if we realize that it's symmetrical here, and that's why there's this small thing that separates the two of them, just to show that they are symmetrical. We have one electron domain right here with the carbon atom going there, and another domain right here going with the hydrogen, and that happens on the other side too. And so there are two electron domains, meaning that the hybridization here is sp. That is the first side, the reactant. And here we have it as a reaction, or the product of the reaction. And same, it's 10, but here we add in 14 electrons because chlorine is in group 17. 7 electrons, 7 times 2 is 14, 14 and 10, 24. Similarly, we realize that there is symmetry in this case, as they're both split into precise twos. And for each carbon atom, again, we have, this time what's different here, there are 3 electron domains. There's one with the carbon atom, one with the hydrogen atom, and then one with the chlorine atom. And every atom here fulfills its octet. And so here, since we have 3 electron domains, it's sp2. So the answer is yes, it goes from sp to sp2 in the changes between both of them. Question 2. What is the hybridization of the carbon atoms in a molecule of ethine, represented above? Since it's already drawn here, and we'll see that here again, it's the other half of the previous Lewis structure. 10 electrons, and then we have symmetry here, 2 electron domains, and so the hybridization here is going to be sp, since we have 2 electron domains. A common misconception here would be that it would be, for example, just 1 electron domain, or maybe even 4. Some people may think that, or 3. But in reality, if there is symmetry in the diagram, then you must split it into 2 to find the electron domains, and you can't take it, for example, like here, there is no main electron. The main electron is the main atom. The main atom here is carbon, but it's done twice, and so that's why it's symmetrical, and there are only 2 electron domains coming out of the carbon, and so it's sp. Mohamed al-Essaily.
Good morning. I will answer question number 3. The question is, determine the hybridization of the nitrogen labeled Y, which is this hydrogen. So this hydrogen is connected to 3 electron domains, which means it's in the sp2 hybridization. because there is only three domains. The next question, question number 4, determine the hybridization of the nitrogen labeled X. This time, nitrogen is surrounded by four electron domains, which means it has sp3 hybridization. Next question. A student claims that all the items in the molecule exist in a single plane. Do you agree with the student's claim? Justify your answer. I disagree. Nitrogen, the one labeled X, is sp3 hybridized, and if you notice, it's the only one of its kind in the compound, and it has tetrahedral electron geometry and trigonal pyramidal molecular geometry. The hydrogen bonded to nitrogen X does not lie in the same plane as the rest of the atoms. It's either geometrically above or below the rest.
This has been Martin Tyler and Alan Smith with you. Thank you for watching.